Let's continue with finding the inverse of a linear transformation. And by the way, this will be the last example, as we are going to deal here with a transformation from R4 to R4. Okay? This is because our vector here has 4 components, and the resulting transformation also has 4 components. This is very important to note, because if our domain is an element of R4, our matrix here, which is the first step of finding the inverse of linear transformation, finding the standard matrix, is actually in an element of R4 as well. So the process of finding the inverse of a linear transformation starts with the standard matrix of our linear transformation. Then let's see if we could come up with its inverse. In short, whether our standard matrix is invertible. And if it is invertible, that automatically means that our linear transformation is also invertible. If it's not, then of course the otherwise. After we are done showing the inverse of our standard matrix, we are going to multiply said standard matrix with a certain vector v. This actually has these 4 components, and we could finalize with our definition or description of our inverse of a linear transformation. So let's come up with the 4x4, okay, standard matrix for this given linear transformation. We're going to use the given here, and take note that x sub 1, x sub 2, x sub 3, and x sub 4. We have 4 columns there. In one column would be all the coefficients of x sub 1, then x sub 2 for another column, x sub 3 for another column, and x sub 4 for the next. Our first entry in our linear transformation is x sub 1 minus 2x sub 2. So we will have 1x sub 1 minus 2x sub 2. We don't have x sub 3. We also don't have x sub 4. Our next entry is just x sub 2. So that's no x sub 1, 1x sub 2, no x sub 3, no x sub 4. Next, we have x sub 3 plus x sub 4. So you have here 0, 0, 1 x sub 3 and 1 x sub 4, and finally 0 0 1 0, because we have here x sub 3 only. This is the standard matrix of this given linear transformation. The next thing we need to do here is to make sure that this is invertible, and if it is, we need to show the inverse. The inverse here, represented by a to the power of negative 1, is identified using a certain process involving the augmented matrix of the standard matrix A together with the identity matrix for R4. Then we are going to apply certain processes here, elementary row operations, to convert this matrix A into the identity matrix in R4, and apply the same row operations to this here. What will be the result? That's your inverse. We will not be using the idea of the determinant as presented in finding the inverse of a 2x2 matrix, since that is again for a 2x2 matrix only. Here we are going to show how it's done here. So let's start with this augmented matrix. You have 1, negative 2, 0, 0. Then you have here to be paired with 1, 0, 0, 0. Okay. That's the let's start with this first. 0 1 0 0 0 0 1 1 0 0 1 0. Then this is the identity matrix for R4. That's 0 1 0 0 0 0 and then 1. Again, the goal here is to find the or transform this into an identity matrix. So this is already a leading one. That's already okay. This is already a leading one as well. By the way, to make this leading one, let's make this 0. So what we can do here is simply multiply negative 1 to row 3 plus row 4 for a new row 4. With that, you will have this form here. The first row is unchanged. So same thing here. The second row is also unchanged. The third row is also unchanged. And the last row will be multiply negative 1 to row 3 to add it on row number 4. So that's 0, 0 plus 0, 0. 0 plus 0, 0. Negative 1 times 1 is negative 1 plus 1, 0. Negative 1 times 1 is negative 1 plus 0, negative 1. here. 0 here as well, 0. Negative 1 times 1 is negative 1 plus 0, negative 1 here, and 1 here as well. Next is to make this leading 1 by multiplying negative 1 to row 4. Okay? 1, negative 2, 0, 0, 1, 0, 0, 0. 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0. We have 0, 0, 0, positive 1, 0, 0, positive 1, then negative 1 here. Now, since we have this, let's try to make this 0 by working backwards. Negative of row 4 plus row 3 equal to the row 3. So you have 1, negative 2, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, sorry, my bad. It's the third row that we are changing. So let's start with the fourth row. 1, 0, 0, 0, 1, 0, 0, 1, negative 1. Here comes the process. Negative 1 times 0, so that's still 0 here, 0 here. Negative 1 times 0 is 0 plus 1, still 1 here. Negative 1 times 1 is negative 1 plus 1, 0. Here, so negative 1 times 0, so 0, 0. Negative 1 times 1 is negative 1 plus 1, 0 here. Negative 1 times 1 is positive 1 plus 0, so 1 here. Then finally, let's make this equal to our 0. Okay, so we're going to multiply 2 to row 2 rather, plus row 1 for a new row 1. Okay, so this is 0, 0. Let's start the bottom because we're working backwards. Negative 1, 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, and then 2 times 1 is 2 plus negative 2, 0. 2 times 1, 0, so 0, 0. Still 1. 2 times 1 is 2 plus 0, so 2 here, 0, 0. Okay. My bad. This is 1, by the way. This is already in a form of identity of our 4x4 matrix. In short, this is already our inverse of A. Okay? The inverse of A is equal to 1, 2, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, and you have 0, 0, 1, and then negative 1 here. With this, we have shown that our standard matrix A is invertible. Hence, this is already a proof that we can find an inverse of this linear transformation T. We are done with this. We're done with this process. Let's proceed here. We're going to multiply a vector using these entries. So A inverse times a certain vector V is equal to 1, 2, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 1, negative 1 to be multiplied with x sub 1, x sub 2, x sub 3, and x sub 4. So you will have this form here. Okay. Yeah. We'll have 1 times x sub 1, so x sub 1 plus 2x sub 2. That's for the first row. Second row is just simply x sub 2. The third row is simply x sub 4. And the fourth row is x sub 3 minus x sub 4. This means that the inverse of our given linear transformation in R4 is, with these entries, x sub 1 plus 2x sub 2, x sub 2, x sub 4, and x sub 3 minus x sub 4. This is the inverse of the given linear transformation following these steps here. So what is the only difficult part here is coming up with the inverse, as this is actually a 4x4 matrix and it needs a lot of processes. But we're just so lucky that in our standard matrix there are many zeros. But if it has more non-zeros than zeros, then we need a lot of steps and patience here. Thank you very much for watching.